we have talked about moving, translating graphs, so we just move them around on the page. We've talked about flipping them over the y-axis and over the x-axis. And so the next thing that your book is going to ask you to do is actually change the shape now. Before the shape stayed the same, it just moved. Now the shape changes. That's not going to distort so much as just stretch and compress. So when we've got a typical graph here, and your book likes to use square or quadratic equations, so the y equals x squared is a pretty common one. It's a really good idea to get yourself used to the pattern of a typical y equals x squared graph, because you're going to see it quite a bit. Now, 0 times 0 is just 0. 1 times 1 is just 1. 2 times 2 is 4. 3 times 3 times 3 is 9. And when you get to this side, -1 times -1 is +1. -2 times -2 is +4. So you end up with this perfect ellipse, and it's always going to be the same. In a normal y equals x squared graph, you're going to see this exact pattern. If I were to move it to the left or to the right, up or down, I'm still going to have the point of origin, and then over 1 up 1, over 2 up 4, and so on. It's still going to be the same thing. However, now we're going to be stretching it or squishing it. So the first thing that you're getting started asks you to do is to multiply it by 0.5. So we want to write down the points that we started with. -2 squared is 4, -1 squared is 1, 0 squared is 0, and so on, so that we've got our basic points. Now we want 0.5 x squared, so basically we're cutting those values in half now. So this is 2, this is a half, this is still 0, a half, and 2. Now, what would that look like if we put it on the graph? We can see that, let's just do these in purple so we can see them when we replot them. So -2 now is going to be 2, -2 and 2, 2 is going to be 2, this guy's going to be a half, this one's going to be a half. So then we know that this original plot's still 0, and we can just kind of extend that pattern up because we know that it's going to follow the same shape. And you can see that when you multiply by a decimal, it's actually compressing the graph, squishing it, if you will. All right. Now they want us to try 2x squared. So now we're multiplying it by a whole number greater than 1. And you can probably guess that the opposite thing is going to happen. So, let's see here. 2 times the original function gives me 8. 2, still 0, 2, and 8. So when I go over here, I'm going to have a plot of 1 and 2, 2 and 8. Now, my graph didn't quite go that high, so I'm going to have to extend it up to here. That would give me 8. So this becomes 2 and 8, 2 and 8, and then there's 1 in here. So I can see that I didn't really, I could adjust this a little bit. Sorry about that bad visual. Still a bad visual. You're going to have to do this in your graphing calculator so that you can get a better idea of what it looks like. But I should have this line inside, stretching it up as if you had just grabbed the ends of that thing and pulled it upwards, making it narrower and taller. So this is basically the pattern that we're going to be looking at. When we multiply by a decimal, we're actually squishing it out sideways because we're shrinking it vertically. When we multiply by a whole number, we're increasing it vertically, which kind of squishes it sideways. your book continues by applying a negative. Now, we know that negatives flip things. So, the first thing they do is negative 0.5x squared, which means that all of these numbers are just going to be negatives now. So I can go negative 2, negative a half, 0, negative a half, negative 2. And what that's going to look like on my graph is this whole thing goes upside down. So it's going to be negative a half, negative 2, and I can see that I've got that squished version of the graph, but it's going the other way. So I can kind of just keep that going, and the purple has been flipped because it was 0.5, now it's negative 0.5. And you can expect that the same thing's going to happen when you have a negative 2x squared. It's just that now I've got these values are negative. So negative 8, negative 2, 0, negative 2, and negative 8, which means that roughly I'm going to have a 2 here and an 8 down here somewhere, which means that my overall shape of the graph is narrow, lengthened, and upside down. So you can see that the last part that we did with the negatives comes in here, as well as a new concept where we're actually squishing or stretching the graph.